In 1895, a paleontologist in South Dakota uncovered something that would force scientists to rethink turtle evolution. What George Reber Weiland discovered wasn't just another fossil, it was the remains of a creature so massive it defied belief. Picture a turtle the size of a small car, weighing between 2.2 and 3.2 tons, cruising through ancient seas 74 million years ago. This wasn't your typical pond turtle. This was Archelon ischiros, and its discovery would reveal that the gentle creatures we know today once had a colossal ancestor that ruled the Cretaceous oceans. But Weiland's find presented an immediate problem that would challenge everything paleontologists thought they understood about turtle anatomy. When Weiland first brushed the sediment away from those enormous bones in the South Dakota Badlands, he found himself staring at something that challenged every assumption about turtle anatomy. The exposed vertebrae and rib fragments stretched across the excavation site in dimensions that seemed impossible. Each individual bone measured larger than corresponding structures in any known turtle species, and the spacing between them suggested a creature of truly extraordinary proportions. The scientific establishment reacted with skepticism bordering on disbelief. Leading paleontologists of the era examined Weiland's initial sketches and measurements, questioning whether these remains could actually represent a turtle at all. Some proposed that the fossils belonged to an unknown species of marine reptile, perhaps related to plesiosaurs or other large aquatic predators that dominated Cretaceous seas. The bone structure showed characteristics that didn't align with established turtle morphology, creating confusion among researchers who had spent decades studying Chelonian evolution. As the excavation progressed, the true scale of the discovery became undeniable. The shell framework, when finally exposed in its entirety, measured an astounding 15 feet from the anterior edge of the skull to the posterior tip of the carapace. This measurement dwarfed the largest known turtle fossils by margins that seemed to belong in the realm of fantasy rather than scientific reality. Even modern leatherback turtles, the giants of contemporary seas, appeared diminutive by comparison. The excavation itself presented unprecedented challenges for 19th century paleontological techniques. Weiland and his team had to develop new methods for stabilizing and removing bone fragments of this size, working with tools and materials that were barely adequate for specimens half this scale. The delicate process required months of careful work with each section of the fossil, demanding individual attention to prevent damage during extraction. When researchers finally calculated the creature's estimated body mass, the numbers defied comprehension. The bone density and structural analysis indicated a living weight between 2.2 and 3.2 tons, placing this ancient turtle in the same weight class as modern African elephants. The implications were staggering for scientists who had viewed turtles as relatively modest creatures throughout their evolutionary history. The morphological analysis revealed features that suggested this wasn't simply an oversized version of familiar turtle species. The skull proportions, limb attachments, and shell architecture indicated potential evolutionary divergence that could represent an entirely separate branch of turtle development. This realization forced paleontologists to reconsider fundamental assumptions about Chelonian evolution and the ecological roles these creatures had played in ancient marine environments. Weiland's discovery opened scientific understanding to the reality that Cretaceous marine ecosystems had supported turtle species of unimaginable size and complexity. The western interior seaway had clearly been home to creatures that pushed the boundaries of what seemed biologically possible for turtle anatomy. The western interior seaway presented a survival challenge that would test any marine creature to its absolute limits. Archelon's evolutionary response to this environment represented a radical departure from conventional turtle design philosophy. Where most turtles throughout history had relied on thick protective shells to shield them from danger, Archelon chose a path that seemed counterintuitive and potentially suicidal. The leathery carapace that covered Archelon's massive frame functioned more like flexible armor than the rigid fortress most people associate with turtle anatomy. This soft shell construction allowed the creature's body to flex and bend during swimming motions, creating far more efficient propulsion through the water. The trade-off was significant. Archelon sacrificed the impenetrable defense that had served land turtles so well for thousands of years, betting instead on speed and agility as its primary survival tools. Those enormous paddle-like flippers represented the true engineering marvel of Archelon's design. The front flippers alone could span between 16 and 20 feet when fully extended, creating a propulsion system that generated tremendous thrust with each stroke. The humeri or upper arm bones developed proportionally massive dimensions to anchor the powerful muscles needed for long-distance ocean travel. Meanwhile, the radii and ulnae of the forearms remained short and compact, creating the perfect biomechanical leverage for maximum swimming efficiency. Beneath that flexible carapace, Archelon's skeletal framework featured a sophisticated system of ridges and reinforcements that provided structural integrity without adding unnecessary weight. The ribs projected at perfect right angles from the midline, each measuring approximately 39.3 inches in length, creating an internal framework that could support the creature's enormous mass while maintaining swimming flexibility. The bone structure incorporated osteosclerotic elements, dense, heavy bone tissue that functioned as natural ballast, similar to the adaptations found in modern whales and other deep ocean specialists. The skull design revealed Archelon's specialized approach to feeding in these dangerous waters. The elongated narrow head housed a hooked beak that could handle an impressive variety of prey types. This wasn't just a simple crushing tool. The jaw structure provided enough strength to process everything from delicate jellyfish and soft-bodied squid to tough-shelled mollusks and crustaceans found along the seafloor. The versatility of this feeding apparatus meant Archelon could exploit multiple food sources without competing directly with other large predators for the same resources. This combination of enhanced mobility, specialized hunting equipment, and structural innovations created a marine predator perfectly suited for the Western interior seaway's unique challenges. Evolution had produced a turtle that could outswim most threats while maintaining the feeding flexibility necessary to thrive in an ecosystem where adaptability meant the difference between survival and extinction. Establishing dominance in waters teeming with 50-foot Tylosaurus and massive shark-like Cretoxorhina required more than just impressive size. The Western Interior Seaway functioned as nature's ultimate proving ground, where creatures needed perfect adaptation strategies to claim their ecological territory. This vast inland sea stretched from the Gulf of Mexico to the Arctic Ocean, creating a marine environment unlike anything we see today, with depths averaging around 600 feet and oxygen-depleted conditions near the seafloor. Archelon faced constant threats from predators that could theoretically overpower even a 2.2-ton turtle under the right circumstances. Mosasaurs patrolled these waters with jaws capable of crushing almost anything they encountered, while prehistoric sharks brought their own brand of terror to the ancient seas. Yet Archelon's sheer bulk served as its primary defense mechanism. Most marine predators of the Cretaceous period were built for speed and ambush tactics rather than prolonged battles with creatures of Archelon's proportions. The turtle's escape capabilities proved just as important as its intimidating presence. Those massive paddle-like flippers could generate sudden bursts of speed that allowed Archelon to outmaneuver threats when diplomacy through size alone wasn't sufficient. The flexible carapace enhanced these evasive maneuvers, allowing the creature to twist and turn through the water with surprising agility for something weighing as much as a modern automobile. Archelon's feeding strategy demonstrated remarkable ecological intelligence. Rather than competing directly with mosasaurs and other apex predators for large prey, Archelon focused its attention on the seaway's abundant populations of jellyfish and squid. This dietary specialization meant avoiding confrontations over food sources while exploiting a virtually unlimited supply of soft-bodied organisms that other large predators largely ignored. The scissor-like jaws could process everything from delicate jellyfish to tougher mollusks and crustaceans found along the seafloor. The temperate climate conditions in the northern regions of the Western Interior Seaway created optimal environments for Archelon's metabolic processes and reproductive cycles. These favourable conditions supported the complex ecosystem that included plesiosaurs, hesperornithiform seabirds, and various mosasaur species, creating a rich food web where Archelon occupied a unique position. Through careful ecological positioning, Archelon avoided direct competition while maximising its advantages in size swimming capability and feeding specialisation. The creature likely developed sophisticated navigation patterns that kept it away from the most dangerous hunting grounds while ensuring access to the richest feeding areas. This combination of physical prowess and strategic thinking allowed Archelon to maintain its position as the undisputed champion among ancient turtle species for millions of years, proving that intelligence and adaptation often matter more than raw power in evolutionary success. When you examine modern leatherback turtles swimming through today's oceans, the resemblance to Archelon becomes almost unsettling. Both species share that distinctive leathery carapace, those massive paddle-like flippers, and the streamlined body design that seems perfectly crafted for open ocean survival. For decades, paleontologists assumed this meant leatherbacks were direct descendants of Archelon, carrying on the genetic legacy of their massive ancestors through 74 million years of evolutionary history. Recent genetic and morphological studies have thrown this comfortable assumption into complete disarray. Scientists now suspect that these striking similarities result from convergent evolution rather than direct ancestry. This means both species independently developed nearly identical solutions to the same environmental challenges despite evolving along completely separate evolutionary pathways. The implications are staggering for researchers who had built entire theories around the assumed connection between these ancient giants and modern sea turtles. The evidence supporting convergent evolution continues mounting as researchers examine the molecular differences between leatherback DNA and what they can reconstruct from Archelon fossils. The genetic markers suggest that modern leatherbacks branched off from other turtle lineages millions of years after Archelon had already established its dominance in Cretaceous seas. This timeline creates a massive gap that challenges the direct descent theory and forces scientists to reconsider the entire evolutionary history of large marine turtles. Archelon's extinction around 74 million years ago resulted from a devastating combination of environmental changes that struck simultaneously. The Western Interior Seaway began shrinking dramatically as tectonic forces altered the continental landscape, reducing the vast marine habitat that had supported Archelon populations for millions of years. As the seaway contracted, available food sources became concentrated in smaller areas, creating intense competition among marine predators for diminishing resources. Climate cooling during the late Cretaceous period added another layer of stress to Archelon's survival equation. The temperature drops affected metabolic processes and reproductive cycles, making it increasingly difficult for these massive turtles to maintain the energy levels necessary for successful breeding. Meanwhile, increased predation pressure on eggs and hatchlings created additional challenges for population maintenance as new predators adapted to exploit turtle nesting sites along the changing coastlines. These combined pressures created a perfect storm of extinction factors that even Archelon's impressive adaptations couldn't overcome. The species that had ruled ancient seas for millions of years finally succumbed to environmental changes that reshaped the entire marine ecosystem. What remains today are fossilized bones and scientific mysteries that continue challenging our understanding of turtle evolution, reminding us that nature's history contains surprises that can overturn decades of accepted scientific wisdom with new discoveries and deeper analysis. Archelon's discovery fundamentally changed how we understand prehistoric life, proving that Earth's ancient oceans supported creatures of unimaginable proportions. Next time you spot a sea turtle, remember 4-ton ancestors once dominated ancient oceans. Recent discoveries like Leviathan achalis, Enigmatica in Spain suggest that massive turtles were far more common during the Cretaceous than scientists previously realized. For viewers interested in exploring more paleontological discoveries, numerous specialized channels continue documenting these remarkable finds as they emerge from fossil sites around the world. Archelon's legacy reminds us that the natural world has always been capable of producing life forms that challenge our assumptions about what's possible, leaving us with a deeper appreciation for the incredible diversity that has shaped our planet's history.